Hi, good afternoon. Just checking in if you can hear me loud and clear.
Okay, sir. Hello, everyone. Welcome to another session of the data series. We will start in 5 minutes. Till then, Let's get to know each other. We have put a poll. Kindly answer the question. Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Omkar Pukamwar, part of the data science team at Analytics Vidya. For those who have joined for the first time, a brief introduction to the DataHour series. The DataHour is a series of webinars conducted by Analytics Vidya and led by top industry experts. It's a fun way to understand the concepts of data science, data engineering, software engineering, and blockchain from leading players in the industry. We are hopeful that these sections are going to be great source of enrichment and value adding for our community members. Now on to our session today, which is Introduction to Deep Learning with Fast AI. I hope you are excited to attend this webinar with us. Before we kick things off, I hand it over to a speaker, a quick recap of the housekeeping items. We are recording this session and the recording will be available on our YouTube channel. The link you will find it in the chat section. Please use the question and answer section for asking any questions you might have during the session, and we will do our best to answer them as the data progresses towards the end. We will be sharing a feedback poll towards the end. You all are requested to kindly fill that up before leaving the session. Now, on to our session. In this session of data, we have Victor sir with us. Victor sir is a student in university in Nigeria, where he studied electronics and electrical engineering at the undergraduate level. After 2 years of experience as a data scientist at Farm to You, an active startup where he helped build data-centric products for farmers in Africa. You can connect with him in LinkedIn. The link will be present in the chat window. We are also hosting the webinar live in the YouTube to our official channel, and the channel link is present in the chat window. You can even follow up from there too. Thank you. Over to you, Victor sir. The virtual stage is all yours.
Yeah, thank you so much for that wonderful, introduction. Yeah, I'll just, proceed to share my screen, and yeah, it's really nice to be here, and thanks so much to Analytics Media for the opportunity to, bring this session to everyone around the world. Okay. Yeah, please confirm if you can see my screen very clearly. All right, I'll use the chat section. All right. So yes, you can just let me know in the chat if you can see my screen. I'm sharing my screen currently, and I'll just put it on slideshow mode now. All right. Thank you so much. All right, guys. So I'll be bringing you the data hour, for the next 1 hour, and I'll be walking you through a quick introduction to deep learning with FastAI. Yes. So the quick table of contents of what we'll be talking about in this on data. I'll take you through what deep learning is with FastAI, what deep learning basically is, an introduction to what FastAI is all about, and why basically you should use FastAI, as a beginner in deep learning. FastAI as well for computer vision. We'll try to see very quickly if we can do a quick image classification challenge on Zindi. And of course, we'll try our best also to do an NLP. I've written down the notebooks which I'll make available, but most likely the NLP one will be a takeaway. Then we'll just walk through, the conclusion and do a quick Q&A session. Yeah, so a brief, story about myself. My name is Olufemi Victor. I'm currently an ambassador at Zindi Africa. I have about 3 years, work experience. I'm helping to build data-centric products across Africa. I'm also currently ranked top 1% on Zindi. Zindi is basically like a very popular platform here in Africa and all around the world as well. It's very similar to Kaggle, where you come around to hack. Data scientists come around as well to do hackathons and help businesses solve problems. And in my spare time as well, I also love to do movie reviews. Yeah, so you can feel free to send me a DM, or if you're ready to talk about movies, I'm always happy to do that. All right. So we have a lot to do, so I'll just quickly dive in. So what is deep learning basically? What is deep learning? right? So deep learning is basically a subfield of ML, right, that involves training artificial neural networks and performing complex tasks. So, from time to time, we've seen the likes of Google Photos. Google Photos helps you to tag photos, of places. We've also seen Siri and Alexa, right? We talk to chatbots as well. We've seen Tesla as well, the autonomous, driving vehicles. All these things are AI controlled, right? And they are actually empowered by, what we call deep learning. And much more than ever, we've seen the likes of AlphaGo as well, that has beaten several masters and several board games, right? So deep learning is basically a subfield of machine learning, but specifically it involves, using artificial and neural networks basically to, perform several complex tasks. All right. So what then is FastAI? I'll just pull up the chat section. Yeah, so you can feel free to drop some comments in the chat. I'll respond to the questions later. Right. So FastAI is basically a popular deep learning library. I mean, a lot of beginners are well familiar with the FastAI library, and a lot of folks that are as well starting out their journey in machine learning, deep learning, will go to FastAI to actually start out their deep learning journey. Right. So FastAI library actually makes it easy for you to build, train, and actually deploy models, right? Machine learning models, deep learning models as well. It provides basically pre-trained models where you can get a variety of tools to get started quickly, right? So FastAI can be used for NLP, can be used for computer vision, and a lot more, right? And I'll walk you through, trying out, FastAI for deep learning. So you might ask, right, why should I, try out FastAI, right? What is FastAI all about? Right? Why should I, start off using FastAI for deep learning, right? So over time, this is it, right? We've seen the advent of, deep learning. We've seen the advent of machine learning, data science, the buzz around AI as well, right? And I mean, there's been a lot of criticism, right, especially regards people that want to try to move into the space, right, the AI space, right, and we've seen how that. All right, thank you so much. So we've seen how that from time to time people complain that they need a PhD to start their journey in deep learning, or they need some of master's degree in mathematics and similar, right, to actually be able to code, right? But that's not actually true, and FastAI actually makes deep learning easy, right? So they've actually brought deep learning down into a very high level, right? Such that you only need basic statistics and mathematics basically to actually be able to navigate through using what's it called FastAI, or building deep learning applications, right? So in terms of accessibility, right, that is what I love about FastAI. In terms of performance as well, we'll see when we do a walkthrough, you'll see some of what I'm talking about regards performance. Also, FastAI as well provides a lot of pre-trained models, right? Integrating with Organ Face, integrating with Team, and a lot more of all those big boys that actually build pre-trained models, right? And when it comes to best practices as well, right? FastAI actually solidifies best practices, right? If you've actually had time to what's it called, explore the FastAI library, yeah, you see stuff like fit one cycle policy. You see choosing a learning rate, a tool that helps you find best learning rates before you proceed to train, right? Validation techniques as well. I mean, there are several best practice strategy that has been encoded into the library and is very useful starting out as a beginner in deep learning, right? And FastAI also has a very wonderful community, right? You can check that out at yeah, fast.ai. I'll just type it out in the chat, right? Yeah, so you can always check out fast.ai. They have a very awesome community, that you can leverage, as you grow in the space. And if you have any questions, you have bugs, you have several things that are affecting you while you're doing your, what's it called, your practice, or you're building something and you're finding it very challenging, you can always go to, fast.ai to actually buzz down your complaints and, get it resolved. Right. So, yeah, I'm actually intrigued to get started. All right. So let's talk about computer vision first, right? So what's computer vision basically? We talk about deep learning, right? Deep learning is the use of neural networks to actually, solve complex tasks, right? And we talked about the fact that, deep learning you can classify to NLP, computer vision, etc., right? So what exactly is computer vision? You see, I have beside me a robot that is looking. Yeah, that's. I'll tell you the story of all these images while we're in the session, right? But all right. It seems I got cut out for some seconds. Sorry, please confirm if you can hear me clearly. Internet is acting up funny right now. Yeah, you can just let me know in the chat section. All right. Thank you so much, Francis. Okay. I'll share my screen again, and hopefully we can kick off. All right. Okay. Yeah. So I would share some links right now in the chat section while we get started, with a hands-on session on what's it called, computer vision now. So I actually have a challenge here. So right, give me 1 second. Let me pick up the link from here. So there's a challenge on Zindi Africa, which I'll share the link in the chat right now. Yeah, that's my personal link. You can use it to log into Zindi now. If you would like to, of course, join this hands-on session. But if not, definitely you can stay back, relax, and watch this. Okay, so I also have a notebook link as well, which I'll share in the chat. So this is the link to the notebook, right? And yeah, so okay, so you can always come up to Zindi. That's where the data set actually is. And you basically should take 1 minute to sign up. And when you go to compete, you should be able to find the data sets we'll be working on, right? And we'll be working on the Spot the Max challenge on Zindi. And yeah, it's quite an interesting one. Okay. Right, so I'll just look for the Spot the Max challenge on Zindi, and you should be able to find it, right? And the second link is the link to the notebook. So this is the link to the live session. All right. So this is the link to the notebook. That's the Collab notebook. So you can just click on that. You can just let me know in the chat if you'll be doing, the live coding. Of course, it's just running of notebooks. So yeah, but you can just let me know if you'll be following along. Right. Yeah. So to actually use this notebook, you'd have to make a copy, right? So you can actually save a copy for yourself in Drive. So Colab is actually a platform where you can use to run um, your notebooks. That's your Python notebooks, instead of using your local PC for building your AI models. Right. Okay. I'll send the link again in the chat, Edward. Okay. 1 second. So you should be able to use this link to access. So you should be able to use this link to access Zindi, and you should be able to use this link to access the notes. I'll send the link again. Oh, okay. I think I made a mistake there. I only sent it to panelists, right? So I'll send it to everyone. Right? So I sent the notebook link. Yeah. So you can just follow through that link to actually get the notebook, and the other link takes you to where you can find the data set. Right. So this data set is actually a popular data set. Was used some time ago. Of course, the competition is still active, so you can as well still join. Yeah, but basically, the challenge was to actually spot masks, right? So, I mean, back then in 2020, while the COVID was at the peak, right? There was a pertinent need to actually be able to spot face masks, right, autonomously, right? So you have cameras at the door, and you want them to actually be able to spot masks, right, before allowing folks to come into the building or enter, right? So that's what the data set was centered around, right? Being able to spot, who is wearing a mask and who is not wearing a mask, right? So if you go down to the data section, you would see the files. The files are available. You can just download this, the train and the test. The train and the submission locally. If you are with me, so you just go to data, right? Let me just put the direct link as well. Okay. In case you want to access the data set, right? But of course, if you are already on Zindi, you can just look for the max challenge. That's where the data is, right? And you'll find 3 files, right? The train file. You can just download that. You also have the sample submission file, and yeah, for the images.zip file, you do not need to download this because this is about 192 MB. So I'll show you a way you can actually get the files directly into Colab without actually having to download or waste your internet at home, right? So let's get started. Some people are intrigued to actually see some live action. So we would actually build a deep learning AI, a deep learning model, right? An AI model, basically, that can actually, spot masks and, tell us if, someone is wearing a mask or not, right? So let's get started. So I expect that you're already on this notebook. You'll be following live. And as I said earlier, you can just, save a copy in Drive so that, you can have your own copy that you can edit rather than editing the master, right? So you can read through, what the challenge is all about, right? So spot mask challenge is, I've said earlier, is a challenge to actually spot masks on images, right? And we're given about 1,800 images. I've taken the pain to actually, type out a lot of comments so that beginners can actually get through, understanding the whole code itself, right? So we are given about 1,800 images of people wearing masks and people that are not wearing masks, right? So the objective is basically to, you want to build an AI model that can accurately predict, if someone is wearing a mask or not, right? So to set up, right, I've mentioned earlier, you can just go to Zindi, and this is where the data is. This is the challenge. It's on Zindi Spot the Max Challenge. And while you scroll down to the info session, you will find a thorough description of what the challenge is all about, as well as the metric that is used to score. If you check the data section in the files tab, you would see the files, right? So you can always, these two files, as I said earlier, they are very small, so you can download them to your local PC. And I'll show you a trick on how to actually download this one directly to your Colab. Yeah, there are also discussions as well. If you like to, take further discussions and talk about problems you are facing. And there's a leaderboard as well, right? You can see a lot of folks already have some sort of perfect score on the challenge, right? So we also would, get started and find out how we can, leverage deep learning techniques with FastAI. Okay, so you can just connect. Just make sure you are using a GPU. You can come down to your runtime, but most likely you made a copy, it will be automatically set to GPU, right? If you are behind and you need some form of assistance, you can of course just let me know in the chat section. Right. Yeah. So to pull up the data, yeah, I promised to show you a trick on that, right? So what you can do is this is 192 MB, and you basically do not need to download the system. So you can actually start the download or pretend to download it, right? Then you can copy the link. Okay. And actually copy the link. Then you replace this. Yeah, the challenge there is, this link that is there is very temporary, right? So you need to actually always, replace the link every time. So you try to start a download, and you download it. So Colab would automatically download this for you. I'm using Core to actually pull it from wherever it is right now. My internet is acting up again. Just bear with me. Yeah, but please confirm if you can hear me in the chat section. You can just, yeah, of course, let me know in the chat. All right. Thank you so much. Yeah. So 1 second. Having a bit of. Okay, so if you can see my screen, you see Colab is actually initializing, and that's it's starting up an instance for me to actually start running the notebook. All right, so I'm connected now, and yeah, hopefully I get to, let's see, I'll try to run this again. All right, so you can see it's downloading, and this is not of course using your home data. It's actually downloading on the cloud itself, right? So I have my 192 MB file, which has been downloaded, right? Which is this. Right? So you can do the same for train and test, but I mean, it's quite stressful. So I'll just manually upload them since it's a very small file. Right? So I downloaded it earlier, and I'll just upload that. Yeah, so Colab is giving me a warning that, once I terminate this instance, the files are gone. So you can just take note of that. But of course, I don't mind. Yeah. So what do we do next, right? We have data sets already in our Colab session, right? And we have to, of course, extract the images, right? The images were in an images.zip format, right? So I'll extract them, and okay, yeah, there's a kind of bug here, so I'll just remove that. All right, so images are extracted, easy peasy, and the images are actually here in this images section. I tried to expand it, but okay, yeah. So let's kick off, right? So what do we need to do, right? We've brought in the data set from Zindi, pulling it via this link. We've also, uploaded the train and the test. That's the sample submission set, the train and the test. Right? Yeah. So also we've also extracted the images directly from the zip file, and that's why you see a folder here called images, right? So what next, right? We're moving to FastAI, like straight up, right? So I've talked about FastAI earlier. FastAI is built on top of PyTorch. It's an high-level API, helps you to actually, train, deploy, and manage your, machine learning and deep learning, tasks, building them more efficiently with a lot of tools, right? Data augmentation to train models, when it comes to community support, and also, in terms of utilizing best practices that even you as a beginner might not be too aware of, right? So, and just to talk about team, right? And that's actually the beauty of FastAI, right? FastAI actually from time to time always integrates with, people that actually, building deep learning pre-trained models, right? So talk of the likes of Organ Face, talk of the likes of Team, right? So FastAI integrates into Team, and you can just, of course, Google more about Team. So Team is basically a library, also a Python library that contains tons of, pre-trained models, right? For computer vision tasks, ranging from, ConvNext to ResNet. I mean, there are tons of them, right? So you can actually go onto Team to find, any pre-trained model you think suits your use case, right? So I'm going to install FastAI and I'm going to install Team in this next line of code. And I'm putting capture here to just, avoid Colab from printing a lot of shenanigans, right? Yeah, so that's installed. So with installations out of the way now, I'll just import the libraries, right? So I'm bringing in pandas, bringing in Team, and I'm importing everything from FastAI Vision, right? Now, I mentioned earlier, FastAI can do computer vision, NLP, among several other, even collaborative filtering and tabular, what's it called? Classical machine learning as well, right? Tabular machine learning using neural networks, right? So you can actually do all those with FastAI and very high level, right? To get started as a beginner. So I'm going to actually import everything here. And I put this here for just some kind of sanity check in case this notebook gets old eventually, right? So you probably want to confirm, the version of FastAI I'm using. So currently, I think it should be the latest 2.7.11, right? So yeah, that's the one I'm bringing in. And yeah, so installations and imports are out of the way. Data is done like very fast, very easy. So we'll take a look at the data set now, right? What data do we actually have, right? So I'm using pandas to actually read the data. I have my train labels, train, of course, the train set, and I have the sample submission as well, which contains the test set, right? So this is what the train set looks like. I'm checking out the tail via pandas, right? Pandas allow, it's a kind of tabular Python library that allows you to, able to manipulate tables and, perform a lot of functions, right? So tabular based functions. So checking out the table, I can see two things, right? I can see the image path or the name of the image basically, and I can see a target, right? 0 or 1, right? So this image actually just signifies the name of the image, right? And the target in itself is basically, if the person is wearing a mask or not, right? And don't worry, we'll check out, some of these images and see what's actually inside, right? So the target is if it's mask 1, no mask 0, right? And we have about 1,307 in the train set that have been labeled, right? And yeah, just general practice, it's very good. You actually set seed. And what I mean by setting seed means reproducibility, right? So in deep learning, I'll be very high level on this. I'll try my best not to go too low level, right? So in deep learning, we actually, when we want to start training, we start off with a lot of randomness, right? Initial weights are random, tunings are random, parameters are chosen randomly, right? So to avoid all this randomness and be able to reproduce your results, because I don't know if you're probably a researcher or someone that of course wants to test things over and over again and get the same things, right? You would want to set your random seed so that you can have reproducibility in your code. Right? So that's just what I'm doing over here, setting up random seed and forcing everything to, be the same every time I run this code. So that's just what that is. So check the data frame again. We've done this earlier. And voila, we are basically almost after doing the whole training and stuff. Right? So what do we do next? Right. So we have a data set. We know that there are images. We want to see what the images contain. And of course, the corresponding targets as well. Try to understand what they mean before we chunk it into FastAI to help us with the deep learning training. Right. So FastAI has a class called the data block. Right. And what this data block basically does is that it takes in the data and takes it and converts it into a format that FastAI can ingest and train, right? So the data block API, in our case now, we are, as I said earlier, FastAI takes a lot of different inputs, right? Images with CNLP as well, if we still have time to do that. Right? So we're taking the image and the category, right? If this was a regression task, for instance, assuming we were trying to predict the age of a person, right, from the image, right, the age of a person from the image, right, that's no longer a category. It's kind of like a regression problem because you have continuous values, right? So, but in this case, right, it's just mask or no mask, right? So that's the category. And I'm basically using a train test splitter, leveraging stratified speeds. That just means that you divide your train set into a specific train and a validation set. Why do you need to do all these shenanigans, right? So when you actually train neural networks, right, there's what we call an update of weights. I do not want to go to low level. It's called back propagation, right? So the neural network itself learns from these images, right, and updates the weights backwards, right? And when we do this, right, we need to actually, validate our results and see if we actually learn it, right, through a validation set, right? So we would split, whatever we have, the data set we have, into a train that would actually, learn from, and a validation set, a small set, where we would confirm how good, the learning journey has been, right, for the AI model. And for this get X, I'm just basically saying go to my data frame and pick the inputs X from here. And for the output, which is Y, I'm saying go to my data frame and pick targets from this column. Right? And would just run that. I'm doing some special things, transformations, like item transformations and dash transformations, and I'll explain what all those stuff mean. Right. So I'm going to create the data loader now. As I said earlier, this is a class, and I'm going to apply the class on my data set. Right. Okay, so I've called the data loader to actually ingest what I have. I've set a batch size of 32, and I'm telling FastAI that it should use the GPU. That's what I'm just saying. The number of workers is 0. That is focus on using the GPU for the batch load. Right. So let's see what a single batch looks like. I'm running this live. Of course, the outputs are already there before, but let's just see. Yeah. So I just ran this code, and you would see images, right? So this is an image that is somewhere in the data set, right? And you can see the corresponding label, right? 0, that is no mask, right? You can see other ones. You can see images of those that are masks, right? You can see here mask, but you can see the images upside down, right? So what's happening? We'll find out. And you can see, this is another image of someone with a mask as well. Yeah. So I'll talk about data augmentation. Right. So I mean, while looking at the data, we found out that there were some augmentations with the image, right? You can see some upside down, right? And that's not actually how they are. That's because I've applied some, augmentation techniques, right? And I'll just do a brief walkthrough of what that actually is, right? So while we're training, deep learning models, right? We actually want a lot of data, right? And we want the data to be sparse. We want the data to be different. We want the data to have some sort of variability, right? So what we do most times, we have, just 1,000 about 1,300 data sets of images, right? And we want to expand the number of images, such that we're able to learn better, we're able to learn more, and we're able to have much more images to actually train our AI model on, right? So what we do then is called data augmentation, right? Image augmentation in this case, right? So what I'm doing basically is to augment some images, right? So I flip some, I turn some, I change the hue, the color, right? And that's what you see that I'm doing here, right? So if you look at this example one where I'm padding images, right? So if you look through, padding images actually okay. The images are actually more than the size I've actually set, right? So what padding images does is it helps you add filters, black filters, of course, depending if you want to pad with zeros or pad with ones, right? So let me see if I can probably expand this to like 512. Hopefully, we can find an image that is not up to that. But basically, what's I mean, the images are really large, right? So, but what padding does is it adds, black, what's it called now? Some kind of, black sides, yeah, to the images. They're actually zeros, and zero is black. So it had a lot of all those zeros, right? To make sure that the images are padded, right, at both sides, at both ends. Because one thing that is very important, while training or while passing stuff through the CNN, convolutional neural network, don't worry about that. We'll get to that. Is that we actually want the images to be the same size, right? So one image, which is 512 by 512 in this instance, we want the next image to actually be the same, right? Because that is the way deep learning models actually train, especially CNNs, right, on and to learn effectively on what's it called images, right? So, and I'm also doing a lot of augmentations here where I flip the image, I flip vertically, and I'm also changing the lighting as well, right? And yeah, again, I try another style of augmentation. Squishing the images this time, right? And what squishing images does, what it does is basically it cramps the images right into a very small size without losing the aspect ratio. Because if I expand the images, and sometimes we lose the aspect ratio, right? And the image can, in most cases, might mean something else, right? You don't want that. So you can use the squish method in that instance, right? Next, I try a random resized cropping. This just basically, resizes and crops out images. Of course, in my specified skill, has 1 to 8, and as well, I'm using just a kind of random resized cropping. And yeah, I want to show you this. So let's look at a single image, right, and see what's actually going on. Because looking at a single image might actually bring out the picture, right? So this is one image, right? This is a single image, and I've converted image to about this about 16, right? So you can see one is left, one is right, and they look like as if they are different images. I mean, it looks like this person is actually taking a picture from another angle, right? Meanwhile, it's actually the same image, right? So that's what data augmentation actually does. And so it helps us to generate several variations of the image so that we can learn more and learn better, right? So look at this is light, look at this is kind of darker, look at this is kind of stretched, right? This is bent and lightened as well. And yeah, of course, you can feel free to check out more on data variation, etc. But I mean, because of time, let's just move really fast. Right? So yeah, for Tin, right? I mentioned earlier that we have a library called Tin, which seamlessly integrates into FastAI. Right? And Tin basically has a lot of pre-trained models. Right? So what are pre-trained models? Pre-trained models are basically AI models, right? That have been trained earlier, right? So someone like Google, Facebook, Microsoft, they've actually built stuff already, right? With their bulk of GPUs and access to tons of resources, right? So you do, of course, you don't have so much. I mean, GPU stacked somewhere in your house, right? So, but of course, you want to build stuff. You want to build stuff that are really cool, really accurate. So you can actually leverage, those training that they've done, right, and pick up the weights from where they stop, right, and continue from there. So basically, what it does is it helps your model to actually understand a lot of things, right? So you pick an what's it called? For instance, you pick a model that's been trained already on, for instance, in this case, the ImageNet, right? ImageNet is one of the popular image data sets, right, and already can classify things, right? So you pick it, then you downstream it on your task. right? I'm trying, of course, to stay very high level. So you can let me know in the chat section any question if I've said something that you don't understand. Yeah, so looking at team, I want to actually use the ResNet model. Right? And you can just use the wildcard, that is to check what images start with res and team. And you find tons of them. I mean, there's so many models, so many. Right? And if you want to know more about, which model is the best, which model can I use to, just check out this notebook. I've included it in, what's it called? And check out, Jeremy is actually the founder of FastAI, and he has actually prepared an awesome content on how you can, navigate around choosing models, right, for whatever you want to do, right. So I'm going to run this just for the sake of running it. Okay. And yeah, you can see the tons of models that are available. And I'm choosing a very small one called ResNet 15. Right. So what I'm doing in this instance is actually I'm instantiating ResNet 15. I'm telling FastAI to set the metric to the accuracy. And of course, the path is, don't worry about the path. The path is the default path. Right. So I'm going to run that, and it's going to pull up ResNet 18 from wherever it is and bring it in. And yeah, of course, you can also check out the best learning rate. I mentioned, earlier during the presentation that, FastAI has, I mean, a lot of good principles, good practices, and one of them is being able to find the best learning rate before you actually start off. Right? So you can run that as well. But for me, I basically want to train and move pretty fast, right? So to train, it's as simple as saying, this learner we've instantiated as ResNet 18, we just tell it to fine tune, right? And you define the number of epochs, right, that you want to fine tune for. So epochs just mean the number of times it's flips through the entire data set, right? So I'm going to run this, and this is what they call building an AI model, right? This point of training is just it, and that's the end, right? And of course, it's much more complicated than this under the hood. But I mean, the beauty of FastAI is that it makes it look too easy. It makes it look like deep learning is something you can actually do in a way. Right? And that's why I always encourage beginners to actually start off, with high level stuff, like know how to do stuff, and come down from there into the nitty gritty to actually understand what is up under the hood. And FastAI, of course, is very good for experts, right, that want to actually dig in and dismantle everything, and also for beginners as well that want to start off their learning journey using in deep learning basically. And you can see it's pretty fast, just about 41 seconds to actually fine tune the model. And I'm training for about 3 more epochs, and let's see what the accuracy will come up with. Okay, so yeah, don't I mean you can drop, yeah, thanks so much, Erica. You can of course drop your questions in the chat. You can drop anything you want to talk about in the chat as well. While this is training, most times data scientists came to probably grab a coffee during their training period, or maybe switch to movies or something, or probably take some time off training. Yeah, but this is actually a pretty short training time, and it's really fast as well, so you can just stay. Okay, so we have about 95% accuracy already, and hopefully we get to about 969 before we get to the last what's it called? Right. So that's validation. You can see we are up to about 96%. And of course, the 96% is basically on the validation set, which we of course stated earlier. Right. And let's see, this is the final lap, because I'm only trained for 3 calls. Of course, you can increase your training time. You can, depending on how deep you want to go. But of course, there's something called underfitting and overfitting, where it gets to a particular point in time, you overtrain the model on a particular data set, right? And what basically happens in that time is the image stops to learn, and it begins to an high level of cramp. Yeah, it begins to cramp the image, right? And the accuracy or the validation loss gets low, right? And of course, you can see something somewhat is happening here, right? That's quite fun, right? And yeah, but anyways, we are down to about 95.4% accuracy, right? So you can probably train some more or train less, or just do some tweaking, right? To get the best out of your training, right? So, but while building this notebook, okay, some stuff must have changed probably the learning rate. I didn't use the exact learning rate anymore, right? Because I didn't want that. So, but yeah, let's just check out the results. So FastAI has a function called show results that shows you what the AI model already has learned and what the result looks like, right? And in the show results section, you can see 1 second, all right? So in the show results section, you can see um, the results, right, from the validation set. And you see here we have the image of the boy, right? He's not wearing mask. And above you see our prediction as well, right? So it looks like, our model was pretty good. It looks like we are getting almost everything right. So let's check out the confusion matrix, right? So the confusion matrix actually helps us to, dig deep into where we're actually missing it, right? To see the overall stuff of the validation set. So what did we fail? How many did we fail? We'll find out, right? So you see we're right here. This is the confusion matrix. And you can see for 64 samples of images in our validation set, we're actually not wearing masks. We got them right. For 3 that were wearing masks, we were actually wearing masks. That's why you see actual 1. We failed them, right? For 61 that were wearing masks, we got them. And for 3 folks that were not wearing masks, right, we failed them. And let's find out, let's go further. Let's dig deeper, right? So FastAI has something called plot top losses that helps you to, sort of, I want to know where my model is making mistake the most, right? That's just basically it, right? And when you plot top losses, you are able to actually understand the model. It's just basically like model understanding, right, of what you've trained so far, and it actually helps you to have a sense of how you want to train better next time. Or even sometimes, for me personally, I've been able to leverage this as well to correct, mislabeled images, because sometimes, human beings have labeled the images, and there could actually be mistakes in the labeling, right? And it's so funny that your model would sometimes get, the image, right, why the person that actually labeled it is wrong, right? That happens that way, and yeah, quite funny, right? So in this first image, you can see probably the head is already, has been probably cut off, maybe due to my augmentation and stuff, right? So there's basically no way I could have known that, this person is wearing a mask, right? And that's probably why I failed, to find out that he's wearing a mask, right? So this is another one. I failed this as well. Not too sure why. This is another one. I failed this as well. I predicted 1, but meanwhile the actual is 0. Right? Yeah. So you probably want to do some more augmentation to actually maybe make the best of your predictions. Right? And yeah. So for this as well, probably you can see some folks there are not wearing masks, right? But someone is wearing mask in the image, so yeah. But anyways, yeah, that's to show you, help your model identify, where you're actually, making the worst. Yeah, so this is actually the worst, basically, right? So, but of course, we have to. 96 point something percent accuracy is pretty much good, right? So I'm going to actually make a submission right now to Zindi, right? And yeah, I'm closing off now. So what I'm doing here is basically I have my sample submission, which contains the test set, and it actually contains a lot of images I need to test, right? And the targets, right? Of course, the targets are not there. Trust me, they are just 0 results, right? So I need to actually, replace that and submit, right? So what I'm doing is I'm telling FastAI, taking the test, right, data set, and to make some predictions on it, right? So that's what I'm actually doing there. Okay, so I'm going to get spreads now, get the predictions, and FastAI is using GPU, of course, again to walk through. Not too sure how many images are here. Let me check the tail. Okay, so FastAI walks through these 508 images and makes predictions, and voila. I can save it and prepare to submit. Okay. So this is just, I'm just basically preparing the sample submission. So, and instead of submitting yes or no, I'm actually submitting probabilities, right? So this is how sure am I, right, that the person is wearing a mask, right? So as it's closer to 0, it means I'm pretty much sure that there is no mask here because I mean, this is very close to 0. And this means I'm pretty much sure there's a mask in this image, right? And that's what we are going to submit. All right. So you can just, I mean, save this. These are your, answers for the target, right? Saved as the starter notebook. So you can just download this. So this will download to your PC. And of course, you can go to your submissions. I actually made tons of submissions already. But yeah, you can definitely, if you are signed up already, you can go to submissions and just submit, right, what you have, right? And let's see what the score looks like, right? So you can see I have 99.4 plus percent accuracy, right? Um, just to confirm the metric, I think it's an area under the curve, if I'm correct. Okay, so evaluation, yeah. So I'm using area under the curve. It's a metric. Yeah, you can definitely check more about area under the curve out. And of course, there are tons of resources out there, especially on analytics video as well, that you can check regards several metrics. Right. So voila, that is it, and we can actually call it a day, right? And yeah, there are basically other ways, I put in the notebook on how you can actually make your submissions better, right? There's something called TTA, which is called test time augmentation. Of course, FastAI convenience functions cannot be beat, right? So this helps you to. So what it does is for your test sets, instead of testing only one image, it makes an augmentation on that image, right? And actually makes predictions on those number of images it has, the variations of them. So for instance, you have one image you want to test, so it actually converts that image to like 4 or 5 images, right? And makes predictions on those 5 images and averages out, right? And that's really pretty cool in terms of helping you to streamline down your confidence, in the fact that that image is actually masked or no mask, right? And yes, I also put everything I've done so far. I was able to do it in just 10 lines of code. I mean, I removed all the explanations, the shenanigans, and everything. And aside the imports, I found out that it's just 10 lines of code I needed, right? I mean, from importing the train test, the sample submission, just 10 lines of code. I was pretty amazed myself. Right? The nose mask, where you create the data class, the data loader, where you create, the model as well. For this case, I'm no longer using ResNet. I'm using Convex Tiny. You can try a different bunch of models as well. I also fine-tuned, and I made my submission in under 10 lines of code using FastAI, right? That's pretty cool, right? So, you can definitely check out more. Yeah. I'll definitely, for God's sake, I'll definitely include more links on where you can, learn more about FastAI as well. And also, if you'd love to go further down the hood as well, I also showed some kind of way you can export your model. Right? For those that are interested in deploying models and you actually want to export, you want to build an app, you want to build something fancy, you want to take this model from your notebook and put it somewhere on your phone, so you actually have to extract that file, right? So I do a quick walkthrough here on how you can actually load, you save the model, right, that you have trained. It's actually just one line of code. You call it learn.export, right? And it saves the model for you. Let me just run that. Okay. So this saves the model for you, and you can actually use that model to make predictions, right? So the model is already saved by that. And this is the AI model, right? It's actually very funny, right? AI models are just files, right? Single files, right? So this is it. I've already pickled it into this file, right? It's about 44.8 megabytes. And I can use that file to actually make predictions, right? So to load the file, I just simply use a class again from FastAI called Load Learner, and I can download an image from the internet. I was able to download this image while preparing the notebook, and download the image from the internet and make an inference on that image, right? I just did that now, and it says the person is wearing a nose mask, right? So, and to view what actually that image is that I downloaded from the internet, Yeah, this is it. You can also check JPEG. Yeah, so this is it that I downloaded. And the AI says, the model says, yeah, it has a mask. Right? So you can also do the same for no mask, mask, and yeah, I'll be glad to actually hear your feedback as to the outcomes. And definitely, just to go back to my slides, and that's just basically it on training deep learning models with fast AI, making submissions, and building an AI model. I mean, it's pretty fast. I was able to do that under 10 lines of code, as you saw earlier, right? And of course, aside computer vision as well, FastAI also has the ability to take you through collaborative filtering, NLP. Even recently, there are more interesting stuff coming up on stable diffusion. Probably, hopefully, some other time we get to do a session on that, right? But definitely, I'll join you guys to check out FastAI for computer vision as well as NLP, right? So just to recap on this session, because we're out of time, right? So we've walked through a quick introduction to FastAI, to deep learning as well, computer vision in itself, data augmentation of images, and of course, model deployment, what it actually looks like to infer on images. And for the NLP task, I already, as I said earlier, that would be a takeaway task. I already even put it in my slide as well, for you to try it out. Right. So there is a very interesting challenge here, which I'll share my slides, of course, and all the resources will be shared with you, definitely. Right. So you can check out the Swahili News classification challenge, and I'll also put a link to the notebook as well. Of course, FastAI well explained, that you can use to actually create classification, algorithms with FastAI to understand and identify news, right, that are written in Swahili, right? So you categorize news written in Swahili, and I'm able to do that under a few lines of code with FastAI. So definitely, I would enjoy you to check that out as your takeaway session, and yeah, feel free to give me feedback on LinkedIn, Twitter. Reach out to me anywhere. I'm always happy to hear from you as well. Right. So for those thinking about what's NLP, right? NLP is simply natural language processing, and it's basically giving computers the ability to understand, human language, natural language. You see the likes of ChatGPT, you see the likes of GPT-3. I mean, a lot of people, there's a buzz around, large language models right now. Right? So that's actually what NLP entails, right? Down to audio as well as text, right? And different forms of human interaction, right? So yeah, and I'll probably have to call it off right now, and yeah, just open up the session for a Q&A. You are yeah, much interested in asking science questions, right? So over
Sir,
to
just
you.
a sec. Before we proceed to answer your questions, I would like to request all the attendees to please fill in the poll about feedback. Sir, I have launched the poll. Please kindly continue with the question and answers.
All right, thanks so much. So guys, please, feel free to check out the pool and yeah, make your what's it called? Your voice is heard. All right, so yeah, there's a question I can see, right? Yeah, definitely. It's a bit fast paced, right? Because I was trying to teach you the old deep learning in that 1 hour, right? FastAI is pretty a very cool library. And that was the point I was actually trying to pass across, right? And you can actually do pretty cool stuff, right? With getting started and without much about deep learning, basically, or the nitty-gritty about the mathematics involved, right? So you can actually always go to there's a very amazing resource, course.fastai, right? So there's an official course from FastAI that actually helps you to understand. It takes you through from beginning to end on how you can understand deep learning with FastAI, and explains in details what you need in your journey. And the creator or the founder of FastAI himself, Jeremy Howard, is the one that actually took the course, and it's actually a university course at the Queen's University in Australia, right? So it's a very standard and amazing course. I've taken myself. I took the one in 2018, 20, and 2020. I've taken about 3 FastAI sessions like that, right? Coursework, right? And it has been really amazing all the way, right? So there are always new things coming out, and that's why in as much as you take the course now, I'm still enjoying you to take the course again next year when it's probably renewed or taught in class, right? And the courses are released for free every time, right? After sessions in Queen's University, right? They are released on YouTube, available for free, and there's a book, right, as well, a Fast AI book. The book is called Fast Book, right? So you can just Google it as well, Fast Book, right? So the Fast Book actually contains a book that was written, and I mean, Fast AI is so amazing that they actually release the book for free, right, as a resource, right? So you can actually check out the Fast Book as well if you love reading, or you can watch the Fast AI course videos. I'll drop that in the chat as well. Yeah, so you said Victor is saying he does not understand how to work with custom data sets like this. So resources that can help. Yes. So for resources, I would enjoin you to actually, well, for me, I come from a very competitive background, right? It started off with machine learning hackathons to deep learning hackathons, and I do a lot of competitions on Zindi, right? So if you're looking for data sets, right, you can always come to Zindi to pick up data sets, right? There are tons of data sets, tons of challenges, and tons of style notebook. So is either you compete for a prize, right? You can see the amazing prize money that can be won as well, or you actually switch off the prize and compete just for knowledge, right? So there are tons of amazing data sets you can leverage on Zindi. How much slower would it be without GPU? Wow, that would be really, really slow, trust me. Well, FastAI is really, when it comes to what's it called? What plays up under what plays on under the hood actually. FastAI is pretty good in minimizing or managing resources, right? So there are tons of convenience functions again. We have FP16 where you reduce floating point rates to probably 16 bits, right? Or they recently last year there was something interesting I saw called gradient accumulation, right? Where you're able to actually accumulate gradients before making that backward propagation. But don't let me go into so many technicalities. But it should have been really slow without GPU. Really slow. But this data set is a small one, so you can definitely maybe it should have taken up to 1 hour in CPU, give or take. Yeah. Okay. John wants another session. All right. Yeah, definitely. The NLP notebooks are available, and in fact, you find the NLP notebook very interesting. Everything is open source. It's available. I'll share the link. Let me share the link for you in the chat because I use some very interesting techniques in the what's it called, the Swahili notebook. And if you check, yeah, let me just share that in the chat section. Share that in the chat section. And if you check the challenge, the Swahili challenge has been on for for quite some time now. And yeah, let me just open that. And if you check the leaderboard, you'll find, oh, I'm somewhere second, right? Probably this guy came and and probably bounced because I know I was actually first for a very long time, right? But I'm very glad, people are actually making moves and coming up with more amazing techniques to actually classify this Swahili news better, right? So the notebook I've actually sent for you would actually take it up to the 4th place, right? So if you're able to run that notebook, you'll definitely be able to get to 4th place because as at the last submission I made, I was able to get to 257, right? Which still ranks you 4th, right? Or 5th, rather, right? So please definitely feel free to join the challenge, check out the notebook, share your thoughts, right? Share with me your problems, share with me your challenges, and your journey as well on LinkedIn, Twitter, and other similar channels, right? If there are no other questions, yeah, I would hand over back to the data organizers. Thank you so much again for having me. And just a form of disclaimer, right, which I put in my slide. Most of the text, that were in this slide, in fact, up to 90% of the text were generated by ChatGPT, including this table of contents, except probably about me, right? And all the images here were generated by AI, right? I didn't copy or paste any image from the internet. They were all AI generated, even my image as well, because you find the image is kind of looking weird, right? I regenerated this image using Midjourney as well, right? So all images in this slide are generated by AI, including up to 90% of the text that were used, yeah, for this session. So please feel free to always, check out, tons of stuff, try out new stuff, especially in deep learning and AI space, and I'll be happy to always hear from you. Thank you so much once again for having me in this wonderful session.
Thanks a lot, Victor. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I am sure our audience found it insightful and hopefully we can conduct more such sessions with you in the future. Uh, I hope you guys have filled the feedback poll. If not, I request you to please fill in the poll about feedback as it helps us to conduct more such sessions. The recording of this session will be available within 2 days on our YouTube channel. The link is in the chat window. We will be back with another session of the data on 25th December, February. The link is in the chat section. Till then, bye bye and keep learning, guys.
All right. Bye, guys.